Okay, let's look at a prominent class of machine learning algorithms, namely supervised machine learning algorithms. If you see supervised machine learning algorithms, the key is this based itself upon the fact that the historical knowledge which you have always has an output variable. That's the basis of any supervised learning algorithms. So we also call it presence of labeled output. Labeled output means for every input value combination, set of input variables with corresponding values, you have a corresponding output variables. In that sense, typically supervised learning will take in as input a Excel kind of a sheet or a RDBMS kind of input because they allow for a typical structured data input. But that's not necessary. You can also use deep learning to provide an image as an input and use deep learning to provide combinations of labeled input-output for supervised learning to take place. So let's not go into that part, but let's concentrate on the output variable and its types and how it classifies the typical supervised machine learning techniques into two. The output variable can be, as I said, it can be a discrete variable or also called as a categorical variable or a nominal variable, basically where the output can only take specific values. In case of spam, it can be two types, either mainly spam and non-spam, or if it is a cancer scenario, suppose there can be three cancer cases. There is no cancer, there is no tumor, there is a malignant tumor, or there is a benign tumor. These will be three categories. Similarly, for a sentiment analysis of a set of tweets, you can say there are positive tweets, negative tweets, or neutral tweets. So in all of them, you know that there is specific number of fixed values for the output variable. Either true, false, or 0, 1, 2, or positive, negative, neutral, or something like that, right? So basically, discrete variables in the output leads itself to a machine learning task typically known as classification. Why classification is a special case of machine learning is because it deals with specific classes of outputs. So you can say that each value of the output variable corresponds to one class. So the task in machine learning becomes a task of taking the original data and putting each of the row into specific classes. That's why it's called a classification task. On the other hand, if you have the output variable as continuous, there you try to look at creating for specific data, you try to create some kind of a function which is representing the output continuous data in terms of the input variables. So what happens is you are trying to use the machine learning algorithm to predict a potential future value. It's not a future class, but a potential future value for a future input value. So in that sense, continuous variables are outputting functions as a result of machine learning, whereas in case of discrete, they are producing classifiers as an output. This is basic difference between classification and we call the output variable scenario being continuous as regression. So if you see the two phases of supervised learning, very popular in machine learning, are classification and regression. Let's look at some use cases of classification. So some of the popular use cases of classification are, for example, if you want to look at spam classification of emails into spam, non-spam, or if you want to look at some kind of a cancer tumor classification, is it malignant, is it neutral, or there is no tumor, or some kind of benign tumor. Or let's say you want to look at sentiment analysis of say movie reviews or say reviews related to movies on Twitter, as is it positive, successful, or is it failure, or is it neutral. Or you can also look at taking a somewhat controversial approach, but you can use classification for this. For example, suppose you want to predict the risk level of insuring a person. You may want to classify it into levels like moderate risk, high risk, no risk, zero risk, low risk, or moderate risk, some kind of levels of risk. But the controversy happens because the same thing probably could be treated as a regression problem, where you can say I am going to predict the risk metric, which is a continuous value somewhere say between 0 and 10. So what happens is the problem formulation is now left to a data scientist or the domain expert device. For the same problem, do you want to treat it as a classification problem, or do you want to treat it as a continuous problem with regression problem as a continuous risk metric which gives you a decimal between 0 and 10. But some other problems which are pure regression problems are things like, say, stock market prediction. In case of stock market prediction, you get different input parameters. It could be script, domain of the script, kind of commodity it works on, kind of prominent export import, weather related information, global news related to stock. These could be different input parameters, and ultimately you can say stock value is something which you want to predict. So that becomes a continuous output variable, and that becomes a hardcore example of regression in practice. Another example is, suppose you want to predict the fuel efficiency of your car based on different metrics like weight of the engine, number of gears, the model of the car, or the different average distance traveled. All that becomes input, and you want to find out what is the fuel efficiency in form of, say, miles per gallon of the corresponding model. So that becomes a specific output which is continuous, which is say something like 2 miles per gallon, 3 miles per gallon, 2.5. It's a continuous variable, and that becomes a typical example of regression. Other examples of regression are, for example, if you want to create something like a score, like a FICO score, which is basically creditworthiness score of an individual based on different aspects related to how the credit card performance is, how their payment spend is, what their consumption pattern is, what kind of high value goods they purchase, or low value goods, etc. You want to give a score, something like say between 0 and 850. So this becomes it could be different credit scores which are continuous and depends on several input parameters. So these are typical examples of either you take something as a continuous output variable with regression, like these examples, or you can have purely a classification approach, or in some cases in Dow, you may want to use either of the two. For example, I gave you an example of a risk metric. It could be a continuous output, or it could be classified into moderate risk, high risk, low risk, or zero risk, that kind of a category. So problem formulation can allow you to describe how your supervised machine learning will correspondingly look at formulating a problem.